Okay, this is the NuPIC office hour for January 12th, 2015. My name is Matt Taylor. In front of you, we've got Scott Purdy, Subta Ahmad, Jeff Hawkins, and Chetan Server. Scott and Chetan are NuPIC engineers, and hopefully you know who Jeff and Subta are. If anybody's listening right now, if you're listening live, you should be able to submit questions through the Google Q&A interface that is on our Google Plus page, the event page for this office hour. So at any point, feel free to start typing in questions, and they will queue up in front of me, and I will choose questions to answer. In the meantime, though, I'm going to show a wiki page that I've already started collecting a couple of questions from the mailing list. Let me see. Yeah, this is displaying. So we can start with this anyway while other people are joining the office hour and queuing up questions. So let's start with this. Does that sound good, you guys?
I thought we did that question before.
Yeah, we've done this several office hours.
Every office hour, we get the same question. We're going to keep asking until we publish something.
Yeah, it's apparently an item of interest for the community, and maybe this is something we need to add to our frequently asked questions.
Is there a previous answer that we can refer people to?
I don't know.
Well, let's go over it for the viewers.
You go ahead.
Let me state the question. So Jeff, this was probably a year ago, shared some of his new ideas on temporal pooling. That page is on our wiki, as you can see linked here. Chandon wants to know what's the current status on these ideas. And I think they want status updates. They want to know how the sensory motor integration stuff is working, how's the research going, et cetera. So he's actually been pointing to an experimental implementation he's found in the research repository that you guys have been working on. So I think he just wants an update.
That's the code base, the research code base.
Yeah, this is where all the work is happening, right, in the sensory motor folder.
Jane, you want to talk about what you did and what's up there?
Okay, sure.
And then maybe one of us will talk about where we're going.
Okay. We're working on experiments that test the capacity of the sensory motor inference algorithms and temporal pooling. And so these tests are basically setting up what we call worlds, which are basically static configurations of unique patterns. And so you will have, let's say 100 worlds, and each world will have, let's say 10 elements. And an element is a unique pattern. It'll cause a unique SDR to show up on the sensor that looks at that pattern. So we have an agent that moves around within worlds and tries to do sensory motor inference and pooling over it. And so it makes a representation in the temporal pooling layer of that world, and saccades over that world, and then goes to another one, saccades over that. And the purpose of these experiments is to see how many worlds we could form unique and stable representations for.
So it's a capacity test.
So it's a capacity test.
We've implemented a sensory motor inference, and we're testing its capacity.
Yeah.
In a generic way, it's really not specific to any modality.
Yeah, they're just SDRs, and so I've been working on this, and I have results for different parameter sets, and I should I've been publishing the raw results on the NuPIC wiki,
the
research wiki. Sorry, the NuPIC research wiki. But I hope to have a write-up, a more detailed write-up by tomorrow. So I'm working on that.
Wow, that's a quick commitment. Wow, didn't give you so much of a buffer there.
Well, this should be hopefully almost done.
Tomorrow, yeah.
So that'll give us a better idea as to the capacity of these algorithms for different parameter sets.
Just wait to publish this video until.
Oh, it's being published. Sorry. So here's the research wiki for anyone watching.
The sort of meeting notes and things like that. I think the high level thing is I think we understand the ideas quite well. and we've implemented them, and we tested them out in various kind of artificial scenarios, and this is kind of a stress test of the ideas. It's not in NuPIC per se, it's all in the research code base. So it's all experimental code base. It's not productized in any way. And I anticipate, we'll have to do a bunch of optimizations and other things before we could actually productize it.
Yeah.
The most up-to-date stuff is in, like you said, in the NuPIC research wiki.
Yeah.
And how confident are we that this is the right algorithm? Just to give people a sense. Like
42.
42.
42.
What's that?
No, just 42.
Just 42. You pick the units.
Look, I think we did, the ideas were laid out about a year ago, and we made some modifications to it, nothing dramatic. I don't think there's been any some dramatic things, a lot of experimentation, capacity, thinking through issues. One of the things we have to deal with is, what are we going to do with this? And I think one thing we've decided to do is we are moving right on to motor generation in the layer cortex. So we're not dwelling and spend a lot of time, like with layer 3 sensory motor, high order inference, we spent years testing that and building the products and things like that. We're not going to probably do that with layer 4, the sensory motor inference, where we've got theory, we think the theory works, we've got some empirical results to tell us how the capacity of it, but we're going to go right on to working on what layer 5 motor output. We started that already a week ago. And so it's going to be a little different. It's not like we have a clear path to like, oh, we're going to put this into some product, or the sensory motor inference is going to be manifest itself in some highly tested way. I don't think we have a plan for that at the moment.
So I have a question about the research work. Has any of the code in the research repository actually made it into NuPIC at all?
We've had to do some.
Sounds like a criticism, man.
No, I'm just curious. I don't even know what the process would be.
Yeah, I think Chaitin's done. We've run into various sort of speed bottlenecks, and Chaitin's has had to implement data structures to speed things up, and so those are in there. I would say the biggest one actually is the temporal memory implementation that Chaitin did several months ago. There's the sequence memory implementation that's in NuPIC today that's used by the OPF, and that's got various shortcuts and other things in it. And so we did a clean implementation of sequence memory, very close to what's in the white paper. And that's what the basis that we're working on in the research code. So that clean sequence memory implementation is in NuPIC, and people can take a look at that. And that's right, the first place to start if you want to understand sequence memory in detail.
Yeah, that's where David Ray started when he started writing his Java port.
Yeah, exactly.
That exactly. He said it was very nice and clean algorithm. So
I think we'll go through the same regular NuPIC review process for anything, just because the stuff in the research hasn't been thoroughly code reviewed. I mean, we do code review, but I think it should go through the same.
Oh, definitely. I mean, we have to hold ourselves up to the same standard as we hold the community.
Yeah.
So, okay, let's go back to that second wiki question. If I can find it. Like that. Okay, this is rather long. This is from Eric Lockian. I hope I'm saying that right. He is the guy who has been writing this continuous HTM library, which it looks intriguing. I haven't tried it myself, but it's all written for the GPU. And he's got several blog posts about it, some conversation on, I think, NuPIC theory about the implementation. He's asking, is there a modification to allow an HTM region to directly accept floating point values despite the SDRs being binary? So this is in relation to the work he's done with continuous HTM. Maybe, well, let me continue the question. Would it be possible to get such a feature as an option in NuPIC despite possible biological implausibility? So they don't know if it is plausible or not. I'd like to make my reinforcement learner run on NuPIC as well, but I would also like to test it on more complex image recognition style tasks. Can't the existing encoders already handle image information? Second question is, I don't know if you saw his blog post, I'll open that in a minute, but I'm using HTM for the routing of a standard neural network to approximate a Q function. This can also be used to perform classification tasks. Would you consider using something like this to post some benchmarks on MNIST or a time series task? I'm confident it would perform very well, considering that the world record, at least at one point, was held by a system that uses sparse code similar to SDRs by Yang. So this is his Eric's blog, and this is a bunch of posts recently about his implementation of a continuous HTM system. We don't have time to read through this right now, but I think a couple of you guys have at least been keeping up a bit with his work. Maybe you can help answer this very detailed question. Maybe you could start with an explanation of what continuous HTM is in his implementation, what the continuous actually refers to.
I'm not actually sure. I've not been following it in detail because we've been really focused on finishing up the sensory motor inference and now working on the motor generation and goal-directed behavior stuff and writing up papers as well. So I've not been following up in detail. I think what he's talking about is having the inputs to the spatial pooler be continuous instead of binary. And the outputs be continuous as well.
Yeah, all the activations and inhibition is all.
Okay, so maybe you know a lot.
I don't know it very well, but just the continuous part, I believe, refers to, like, when we do inhibition, we select a bunch of columns, they're either active or not. I think in his case, his inhibition step and other steps leave the values as floating point values. And
so is that kind of like a softmax rule, or do you know it?
I'm not sure.
Okay.
I too saw there's a lot of conversations about this on the email threads, and but I haven't been reading it. So we've been just really busy trying to get our papers written, and so I figure, well, a lot of good people talking about it. I'll find out what it is later. But other than a very cursory understanding what it is. So I don't. We have a philosophy about this. Right? I don't think we're for or against it or anything like that. It's just something we're not terribly familiar with. I'm not sure why Eric, if he needs help, or if he wants to do this on his own, or if he's trying to propose that this gets adopted universally. I think it's fine and great that he's actually experimenting on his own on this, and maybe some other people too. But I know at the moment it's not something that I feel like there has to be some sort of consensus about it.
Well, with regards to his question, is it feasible to make modifications to allow an HTM region to accept floating point values despite binary SDRs? It doesn't quite make sense.
No, the HTM regions are all floating point. The interface is all floating point anyway. And some regions like the spatial pooler and sequence memory, the core HTM learning regions, they just convert the floating point to binary before they use it. So the NuPIC infrastructure is all floating point. Mm-hmm. So if you wanted to create a new region that, instead of doing that binarization step, directly use floating point values, you could do a pull request and try to do it, or get consensus from the community around it. You know, like our encoders, our scalar encoder takes in floating point and outputs binary values.
There are even image encoders, right?
There is an image encoder in their image sensor region. It hasn't been used for years, I think, but not much. But you know, it's still there. It's working.
It's like saying, I have a car that's been in my garage since 1955. It's fine.
We've used it a little bit, but very little.
So I don't think that Eric has been working directly with NuPIC.
Okay.
I think he's done his implementation entirely based on the white paper and our documentation. Actually, I think he's at Windows. I think that's one of the reasons he hasn't built on and using NuPIC. At least I've chatted with him a bit on Gitter about it. So it might be hard for him to actually do this, but he's thinking about it. So I think he mentioned trying to get a hold of a VM so he could build and try and use NuPIC.
Yeah, I'd be interested in a high-level summary of all this. I don't know what a Q function is, and you know, I don't know how much he deviated from Eric, how much he deviated from the implementation in NuPIC today, or the principles of HTM, whether you adhere to them very closely or differently. You say they might be biologically unrealistic. It's not clear why. I've always viewed that our HTM model is also somewhat unrealistic in that the brain isn't completely binary. But because of the nature of sparse patterns and sparse distributions, you can run it in binary and you can get almost all the benefits for it. And it's a lot simpler to code, and it's not clear what benefits are, the marginal benefits versus the computational simplicity. So if it was a very simple cogent argument about the point for this, it would be good to know. By the way, also people who are looking at implementing hardware versions of our algorithms, this is a big issue for them, because if it can be, everything can be done in binary, it makes a huge difference for how future hardware platforms are going to be built. So we're going to try to stick with that if we can, because it has tremendous benefits in numerous ways, software implementations, but also especially hardware implementations. So to abandon that would be pretty, we have to really, really have some important essential elements that we can't capture otherwise. So the same thing happened in computing early on. It's in a kind of roughly analogous way, between the analog computers and digital computers. Not a great analogy, but similar.
Okay, so we do have some viewers watching right now. I want to remind you guys, if you do have a question, use the Google Plus QA interface to enter it, and I will queue it up. In the meantime, Subutai said he had a topic he could talk about. Didn't you? You did say that.
I could. We're running out of questions.
Well, I haven't got any questions yet, except for those two on the wiki.
Okay.
So now would be a good time.
All right. Well, this is
filter through.
All right, fine. This is kind of a very side topic. I spent a couple of days over winter break just experimenting with mixture models and ensembles. So if you're not familiar with mixture models, it's kind of a generic technique in machine learning. If you have a learning system, you can take a bunch of learning systems that are trained differently and combine them very easily to create an even better machine learning system than any of the individual models. So there's a mechanism to do that. It's very simple. And most of the Kaggle competition winners and stuff use ensembles or mixture models, and those are typically the best performing models. So I was kind of curious, like, could you do that with HTMs? How would you do it? And so I did a little project on that. If you go to NuPIC.subutai, you can go to that.
I didn't know such thing existed.
No, it's under Numenta.
Oh.
It's a GitHub.
GitHub.com.
Yeah. Yeah, there you go.
Okay. Nope.
Oh, maybe it's under Subutai. Sorry.
Yeah. Okay. Let me share my screen real quick.
We're talking about this mostly because we don't have any other questions, I think. But these are a bunch of different experiments I've done at various times. But if you go up there, click on ensembles. So I did a little study looking at the HotGym example that we have. So it's a prediction example. And what I tried to do is say, okay, suppose we did a mixture model of HTMs that are all working on HotGym. Could we do any better than the standard ones? So what I did is
the standard one was pretty optimized.
The standard one was pretty good on the. So that's a single HTM region, if you will, making predictions and so on. So what I did is this code runs 14 different HTM models on HotGym data, and what it does is that there's two different ways I looked at to combine them into doing a better prediction. The first one was just to take the average prediction at every time step and make that the prediction instead of taking, the single model's prediction. And then the second thing I did, is an average assumes that all the weights are identical, and instead you could try using least squares to find the best combination of weights instead of just doing a straight average. So there's a
best combination of predictions, you mean?
Yeah, so an average would just treat each model as having the same weight, and with least squares you could vary that weight.
By an intelligent way?
Yeah, it would vary the weight in a way that
predicts
that optimizes the error.
But you won't know that. You can't know that looking forward, right?
No, you're always looking back.
All right. So basically, over the recent history, which weighting of these things would have made the best prediction?
Right. And it actually worked. So if you go to my wiki, or that readme again, I have some numbers in there. I was actually kind of surprised how well it worked. So if you go to the results, I looked at squared error. And if you look at any individual model, the errors went from between 113 to 141. But then when you took the average of the models, the error dropped down to 84.5, which is quite a bit better than even the best individual model. And then the least squares ensemble, which allows you to vary those weights a little bit, got a little bit better than that, and got about an error of 75. So I was kind of happy with that. It shows that some of these principles that, at least there's one principle of being able to combine predictions can be used with HTMs as well to get an even better.
You're saying 38 times better because of the square?
No, it's an absolute value of 30.
Oh, I see. Oh, I'm sorry.
Than the best model.
30. Absolute value. Sorry. I was going to say that's weird. Okay, that's great.
So anyway, all the code is there. It's very simple. There's a different hotgem. It uses the same hotgem parameters that we typically use. The only difference is that I'm varying the random seed and I'm varying the encoder resolution randomly.
And did the standard deviation go down as well?
Yeah, if you look down the standard, normally the standard deviation of the errors were between 285 to 420. The average ensemble, it went down to 200, and the least squares ensemble went down to 183.
That's great. That's a big improvement.
So it's quite a bit better than any of the individual models.
Wow.
Cool. And the trick here is obviously you can't have all the models be identical. They have to be different in some way. So I vary the random seed and the encoder resolution. So
why the encoder resolution of all the things to vary?
I felt that would have the biggest random impact on the output. You kind of want a bunch of randomness in the output in order for ensembles to work. And I thought this was a reasonable. This is one of the biggest factors in the prediction. But one thing I put in my readme is that, well, you could try out. There's all sorts of other things you could try, and maybe you get even better results. So I didn't have time to do all that.
Well,
I spent like one or 2 days.
It's pretty cool, I think, because
It's like a hackathon project.
if there are some prediction problems where the value of the prediction is very high and you can afford to spend a lot more resources on it. And that was a pretty optimized solution, hotgem.
Yeah.
The results were really good before.
Yeah.
So this is much better.
It'd be interesting to see a comparison of the predictions over time.
Yeah.
With this.
Yeah.
I mean, this is something that could be potentially added to the OPF API. Right?
It could be, yeah. I mean, it's really trivial to do.
Yeah.
I mean, don't even do the least squares, just take the average, and that gets you most of the way there.
We have some questions, one from Eric and one from Virgil.
Yeah, we got a couple questions.
Hi, guys.
Okay, this is from Eric Lockett, who we were talking about earlier. I know this question is annoying, but I do think HTM can perform very well in it. Any plans to release a benchmark, perhaps using network routing? I'm confident it would perform well. I tried it on Kaggle and it was great. We're talking about applying it to network routing, which is a topic that's been around for quite a while. Rick, our friend Rick from Australia, is constantly reminding us that that's our killer app.
That's the killer app. I know he's told us that. Someone want to go kill it.
No.
So is this
Well,
question?
why can't he? I mean, if it's working great, that's the whole point of an open source community.
Yeah,
Is
go for it.
let the community contribute.
I think he applied it with his continuous HTML project.
Well, you should do it.
Yeah, why not release it in some way?
That'd be great.
I don't think he's put code up for that, right?
I haven't seen that.
Yeah.
Is it? I don't remember this. I
Posted,
wasn't following the
let's
Kaggle
get
competition.
No, not the Kaggle, his continuous HTML.
Are you sure?
Yeah, he's posted the source code for this continuous HTML. It's got a very long acronym. GPU CHTM or something like that.
Like GPUs at the end. But
Yeah, whatever, CHTM GPU. But as for the Kaggle code, I don't know if he's posted that. His network routing thing. He said, oh, I meant routing as a standard neural network through the HTM. Oh, that's totally different.
I don't know what that means.
I don't know what that means.
Sorry. Hey, Eric, could you explain what you mean by that? And in the meantime, I'll go on to Fergal.
As for benchmark, is there, should we talk about.
Yeah.
It's not the same type of benchmark, right? He's not talking about anomalies. The NAB, or the NuPIC anomaly benchmark project, is just entirely focused on anomaly benchmarks.
Yeah, it's anomaly detection.
So I think that's
He's
just.
talking about prediction.
I assume he's talking about prediction, maybe. And, yeah, Eric, if you want to clarify, are you doing predictions or anomaly detection work with in reference to your question? So let me jump over to Fergal while Eric is responding. Fergal says, what is your take on Jeff Hinton's idea of capsules and Jan LeCun's recent questions about what processes are happening in the brain? Jeff?
I saw Jan LeCun's talk, a recent talk. I don't know what he's referring to about, I mean, I saw Jeff Hinton's recent talk, talking about capsules, but I don't know what.
He's talking about that list of questions that, posted.
Yeah, that's one thing, but there's also
There's questions about
capsule.
what processes are happening in the brain. Maybe someone else.
It was like all these questions about figuring out machine intelligence, like all these questions we had for how it works. Remember this?
Maybe I kind of remember. It obviously didn't. I kind of, that sounds familiar, but it didn't stick in my head. You're talking about Jan LeCun,
Yes.
right? So I think that's different from what, there's two questions there.
Yeah, there's two questions.
What Jeff Hinton's talking about. Did anyone else watch that talk from Jeff Hinton?
I haven't
Or read anything about it?
Few minutes of it.
I watched most of it, not all of it. Whoops. So I don't feel totally up to speed on it, but a couple of things struck me. One is that, hey, it's great that Hinton wants to go beyond what deep learning is, right? He wants to go beyond that because what happened back in the 80s and early 90s with backprop is they never got beyond it. They just stuck on that forever. And it's just basically the same things happening now. And so, the idea of saying, hey, we need to do new things, whatever those are, I think it's great. And I think the sense that I wish he was actually paying more attention to the neuroscience, but he's not. Even though he's calling these capsules mini columns, I don't think they have absolutely anything to do with mini columns. So it's an unfortunate use of the term for something that it's not related to, I think. So it's better to just call them capsules. And I haven't really spent a lot of time trying to understand exactly what he's trying to get at there. It's on my to-do list for this year, or this month, but if no one else is, then I can't talk too intelligently about it. But he was saying, oh, we're talking about mini columns. I was listening, no, that's not mini columns. So, but it's great that he's going beyond that, but I'm not sure what exactly he's doing yet.
That's a very focused term, mini columns, to be not the right thing.
Yeah, I know. Well, yeah, that's the problem with the neural network community is that a lot of them don't really pay much attention to neuroscience, but they like to use the term. And the whole idea of an artificial neural network implies that it has something to do with neurons and networks of neurons, but it really doesn't. Those are not like neurons at all. If anyone knows HTM theory knows that the point neurons that are used in ANNs are not neuron-like. That's the big deviation, perhaps one of the big deviations in HTM theory. And the networks, they tie them together. The deep learning networks are not anything at all like what you find in brains. So it doesn't mean you can't get interesting principles out of them. They can't be really useful. It doesn't say anything about it at all. It just says they're not brain-like or neuron-like at all. And so it's a bit unfortunate if he starts using the term mini column. I think capsules are a better term. Just let him make something else up for what he wants to accomplish. And do you, Scott, maybe you remember Jan LeCun's questions? They didn't stick in my head.
He has some questions about, like he was saying all good machine learning things optimize the cost function based on a gradient, like where is that happening in the brain?
Yeah. They didn't
all
resonate
sorts of
with
stuff
me.
like that.
Well, he just starts right off. Brains appears to be a kind of prediction engine. How do you translate the principle of prediction to a practical learning paradigm? Well, I think we're doing that. Machine learning, what's that?
There are some questions in there that address Numenta specifically, and his response is basically that HTM doesn't address any of my questions particularly well. So.
All right. Well, he doesn't like what we're doing. Good machine learning paradigms are built around the minimization of an objective function. Does the brain minimize an objective function, and what is this function? I think good. I think that's a good mathematical technique that was developed starting in the 80s. And it's been successful in artificial neural networks. I'm not sure it really has much to do with the minimizing an objective function. It may not really play out in the brain at all. We don't certainly think about it that way. I don't think about it that way. You don't think about it that way?
No.
Well, I think that's what it is. A learning and prediction engine, which is his first question. And I think we do have a lot to say about prediction. But if someone wanted to take a stab at going through all these questions, go for it. It was a lot.
I think Fergal did.
Oh, good, thanks, Fergal.
Yeah,
Well, there's a bit at the end there, if you go back to that screen.
Oh, okay, hold on. Let me go back to at the bottom. The
Yeah,
comments.
no, up higher. There's a question around, how does the brain perform planning, language production, motor control sequences, and long chains of reasoning? Well, the planning and motor control is what we're focused on right now.
Yeah, we're doing that.
That's what we're trying to understand. So we agree that that's an important set of properties for intelligent systems.
We have answered something that I just saw another question there. Go back on this. About spikes. A little bit. Yeah, it says the brain uses spikes. Do spikes play a fundamental role in AI and learning, or they just made necessary biological hardware? Well, we have an opinion about that. In the cortex, they appear mostly to be to the latter. We don't think they have a fundamental processing role, information processing role. It is not true other parts of the brain. In other parts of the brain, older parts of the brain, individual spikes do have a processing role. But we don't have any evidence for that, at least not very good evidence for it at all in the cortex. So, anyway, if Fergal went through this, good.
Yeah, he wrote a blog post in response.
Fergal's usually pretty good about all these things, so.
Yeah.
So thanks, Fergal.
Yeah, Fergal, you had a great response on the mailing list to some of those questions recently too. So I can't get your blog to load anyway, so I'm going to stop sharing the screen. But okay, I hope we addressed some of what you were asking about, Fergal. I think we can go back to Eric, who's added some amplification to his original question. He says, basically, a standard neural network goes through the HTMs on cells and can perform classification using back propagation. The HTM acts as a sort of intelligent dropout, which makes it extremely efficient and regularizes it as a bonus.
So you're saying each HTM cell is a back prop neural network? I'm not following.
It's using a neural net to classify an HTM network.
What is it?
That's what he's using as a classifier.
Oh, I was using it as a classifier outside.
Is he doing that, or is he putting the HTM on top of the neural network? That's what it sounds like there, to do kind of random dropouts and stuff.
Let's see if I can invite him. He might want to talk.
I'm not sure what we don't have any plans to do anything like that.
Yeah, I think this probably falls into the category of interesting things that you can do that aren't really our focus.
Maybe a little philosophy, at least my philosophy, it doesn't have to be anyone else's philosophy.
Wow.
Can I talk?
Oh, please.
The whole idea behind Memento and NuPIC is, at least our approach to it, is we're going to keep sticking to the biology. And yet, at some point, obviously, you don't have to do that anymore. And you can fork off and do all kinds of crazy things that biology doesn't do. But we still feel we're learning from the biology. We're still learning the core principles. And now we're working on motor behavior and these core principles. And that, until that becomes unfruitful, we're not going to abandon them. But at any point in time, anyone else can abandon them and fork off and do something. Look at cortical I/O. They started with just the idea of SDRs, and they turned that into a very interesting business. And that's when they forked off. Maybe they'll start using more HTM stuff in it. But so I'm not saying that. I just want to make sure that we're not discouraging anyone from doing what you're trying to do, Eric. It's just that we're all like a research team, and we're going to stick on the brain stuff for a long time until we find out that that's enough of it. Then we can do something. Then we can start applying it in clever ways that nature hadn't figured out yet. But you can fork it off anytime you want and try it out. So that would not be a biological thing. Back propagation doesn't really make sense in biology at all. Although some people keep trying to make it sound like it makes sense. But so what? Doesn't matter. You can make something really interesting this way. Go for it.
Okay. I invited Eric to join if he wants to discuss. I don't know if he will or not. But in the meantime, we'll go back to Fergal. Says, do you have any preliminary responses to the ideas of the math of HTM, this first Subutai, efficiency of predicted sparsity in the multi-layer model in my recent posts? Do you want me to go to them? I think.
Yeah, that might be helpful.
I can't get his blog to load, though.
honestly, I have been so heads down lately. I haven't been looking at other stuff.
There we go.
So sorry, Fergal. I haven't looked at it.
I'm looking at, yeah, I don't know if we can answer your question, Fergal. He has made several recent blog posts, but I don't think we haven't had time to keep up with them.
I think
Okay, Fergal, I'm sorry, I had same thing. You know, I've been really focused on the paper, so I've not had a chance to look at it, but I will take a look at it and try to come up with some opinion.
yeah, Fergal does a lot of stuff. If you have specific questions, that might allow us to get to it quicker. Because especially that post I looked at and kind of passed on reading it because there was a lot of math in it. It would have taken a lot of time to understand all of it.
Well, I think it's a general issue. There's a lot of communication goes on nowadays where, I've spent the entire day trying to read what everyone's writing about, and they just, I just can't do it. I would have to, and we've given ourselves some priorities here, so it ebbs and wanes with how much time we spend on the online stuff. But right now, we are totally focused on getting a couple things done. And we also have a product we're building, so there's lots of stuff going on here that keeps us from being able to engage fully in all the different ideas out there. That's not a...
But Fergal, I will take a look at it sometime within the next couple of weeks.
Okay, so we don't have any more questions. Do we have anything we want to talk about to the community? Any status updates on the work that you guys have been doing? Anything that we need?
I think we already talked about the sensory motor inference status update.
Okay.
I don't know if there's any other.
No, we just 2015 is our year to try to flush out completely the motor stuff. Don't know if we'll be able to do that. I'm optimistic we can, but can't promise it. So we've started having intense discussions around here about that, and we'll keep you posted when we figure anything out.
Yeah.
So.
And from my perspective, last year we did this thing where at the beginning of the year we sort of asked the community what was the most important work that they thought should be done in NuPIC, and we got kind of a good cross section of what people were most interested in, development-wise. So I'm probably going to end up doing the same thing after we release NuPIC 1.0 or 0.1, just to get an idea of what the community is still thinking. We made progress on what our initiatives became from that last year, and so I just want to keep it updated.
That's a great idea, although make sure we review how we did last year.
Yeah.
And, that's the whole point of it, right?
Yeah, that'll be part of it. I might make that its own meeting and just sit and talk about our progress, our yearly status, or something like that.
Yeah, I don't know if you shared the chart with the community on the growth, number of messages and number of followers and all that.
I haven't.
You haven't. That might be an interesting one.
Okay, I'll make a note of it.
Is that something you can pull up right now or not?
Yeah, just
Put you on the spot for a change.
You guys fill up the empty space. Talk amongst yourselves. Let's see.
Oh, yeah, Matt has been tracking a bunch of metrics. So let's see.
That's different than the objectives, what we should be working on.
That's right. Yeah, that's different.
Okay, let me share this. Let's see if I can share this. Can I share an application? I'll just do the whole screen. Did that work? Yeah, that worked. Okay, so this is a comparison slide. Might be a little bit hard to see.
Blue is 2013 and red is 2014.
I hope this works. No, this isn't working.
Yeah, just the previous view was fine.
Okay. So the lower bars, the blue bars, are from basically all of 2014. Wait, 13.
13.
I've got the dates kind of whacked out, but this just shows a pretty decent increase in all of the metrics that I've been keeping track of. If you disclude contributors, which was the smallest increase, we've got an average of about 300% growth across the board. And this includes mailing list messages and subscribers, and those are the things that really balloon up a lot, especially the messages. But it shows a healthy growth. So we're doing well. We're on track. This growth like this continues over the next year. Great. Yeah, I think we'll be very happy.
It's kind of hard to maintain that growth,
Yeah,
but maybe.
Maybe.
we'll see.
I mean, this is pretty encouraging because when we first released NuPIC, we weren't really sure if anyone would take it on or would people really be able to understand it and work with it and
Yeah,
be interested in it. And at least this is really encouraging.
yeah. So we've got 125 contributors right now and lots of followers. 2,653. That's really healthy when you look at other GitHub repos. That's a healthy amount of followers and work. So I'm very happy with that.
And particularly, I mean, we're still pretty niche. It's not like an operating system or a database or something that everyone will use. It's a pretty niche.
Start using it.
Yeah. It's pretty niche, hard to understand.
Yeah.
True.
All right, we're done?
Eric said he couldn't join. I'm sorry, Eric. Fergal wants to know an update on the spring meeting, your meetup. Oh, yeah. I sort of mentioned this. So I'm planning a spring hackathon. We always do a spring hackathon. I have not nailed anything down yet, but I'm going to try and do this on the East Coast. Before that hackathon happens, I might have a meetup in the same venue we end up having the hackathon. When I plan that, I will obviously let the whole community know through the Discuss mailing list, post on Twitter, Facebook, and all that stuff that we're going to have an East Coast meetup. I will be there. Hopefully we can get Jeff out there for that, and just have maybe just like an introduction to NuPIC sort of meetup on the East Coast. Test out the venue for the hackathon so I can meet the people I need to organize the logistics and everything. I don't know the dates or times or anything like that yet, or the location. So I'm planning on it, but I haven't nailed anything down. So that's one of the things I'll be doing by the end of this month is getting all that set in stone and making the arrangements. So sorry, no more details, but I am planning on it. Okay.
Okay.
That's it. A little bit early this time, but that's fine. Thanks everybody for joining in and watching, and thanks you guys for sharing your thoughts on the progress and everything with the community. This has been the NuPIC Office Hour of January 12th, and we'll see you on the mailing list.
Bye.
Bye.